going to be off by 1, I think.
Yeah, because of that.
Oh,
Yeah, just so everybody knows
okay.
that.
All right.
Were there 32 questions on the?
No. There's only 26.
Oh, I
Oh,
didn't
boy.
do the whole thing either. I only got through 14.
Well, okay.
That's
Good.
We can work through them together.
Okay.
Here.
All right.
Guys, they're different.
No.
They're different
Why
than what we
The first
studied.
one is the same.
No, if you look at the review questions, we are 90% confident that the true mean heart rate is between 45 and 105 is option A in the review,
Oh,
but that's not option A on the quiz.
but the answers are all the same. We just have to.
Answers are the same, but we're going to have to go back and just
Yeah.
make sure that. Okay, so really it's not A.
Oh, so I did all of mine in the book. So I have my answers circled. So I don't know. Did you just do A, B, C?
Yeah, I did. So I'll just go back. I'll just look at it and see.
Okay.
I'll just go back and forth and make sure that, yeah.
Well, I'm gonna have to go get a pencil. I'll be right back.
Okay.
Okay, are we ready?
I am, yeah. Sorry.
Yep. So then, question 2 is given a 90% confidence interval of 45 and 105 for the mean heart rate. Which of the following is the best interpretation of this confidence interval? I have, for this particular one, I put B.
Yes.
That's what I have.
Okay.
Yes.
The next question. The researchers decided to construct a confidence interval to determine if the differences of the means is significant. To determine whether the confidence interval would be reliable, they create QQ plots of both random samples and see if they're approximately normal. Are the requirements for constructing a confidence interval satisfied? Why or why not? Let me go just see if the answers line up for this one or not. I put...
They don't.
What did you guys put for this one? Oh yeah, they don't match up. Okay, so I put...
Was this number 2?
Yes.
I had B, whatever that equates to. I can't remember now.
Yes, that the distribution of the mean of each sample is normal since the data have been determined to be.
So I also put B. So
Okay.
I believe for this one it's C.
Yeah.
Okay. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? I had put D.
That's what I had for number. For this.
And looks like D is, oh boy, go back up. D is confidence interval for the difference of means using independent samples.
The C.
So C.
Oh my gosh, could they make this any more difficult? Okay, so the answer is
C. In the quiz. Mm-hmm.
liquids.
Okay. Then number 4, number 5, not 4. A researcher is interested in estimating the savings account balance. She obtains a savings account balance of a random sample of 30, 95% confidence interval. For the mean account balance of bank customers is found to be those values, which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval. So I put C.
I
I
put
put
D.
I put B on this one.
Oh boy. You
Yeah.
put which one?
I put B.
Of
B is in boy or D is in dog?
Sorry, B is in boy.
And I put D as in dog.
I put D as in dog.
Okay.
Because when your sample goes up,
When your
Yeah,
margin
then
of
the-
error goes up,
Yeah.
or when your margin of error goes up, when your confidence interval goes down, your margin of error goes
Up.
up.
Let me just look in my
And
notes.
so let's see, what do we have here?
so in my
The
notes, it says,
The answer on this should be D on the test.
None of the above.
No, D. Obtain the balances of 90 bank customers rather than 30. Because they want to know what's going to make the margin of error smaller. When the margin of error goes down, the confidence interval also goes down, and the N will go up.
where did you
Well,
find the N?
when N goes up, the margin of error and the confidence interval both go down.
That is correct. I had that written down on my paper, but for some reason picked C instead of that one. But I have also in my notes that as the sample size increases, the margin of error decreases.
Mhm.
Which is what we want.
That's what we want.
Which of the following would produce a confidence interval with a smaller margin of error?
Okay, so let me just make sure. So when the sample size goes up, the margin of error and the confidence interval go down.
Right.
Okay. So we're saying that obtaining the balances of 90 bank customers rather than 30.
Mhm.
Yeah.
Okay.
Yeah, I feel good about that one.
Okay.
Okay, and then the next one, so I just did that. I just drew that little graph where you have the mean in the middle, and then the standard deviation was 2. So I just went up by 2, went up by 2, and then down by 2 and down by 2. And I got 996 and then 1,004. Did you guys get that?
That.
Yeah, in the book I got A.
Yeah. I got
That's what I got was A, but I don't remember what the number was, and I don't see that I wrote it down.
So this is one that I did write down. So you take the confidence interval, which would be 1.960, because that's the z-score, and you multiply it by 2, which is the standard deviation divided by the square root of n. So it's 1.960 times 2 divided by the square root of 4. And the number that I got, I can't remember what the number, I think it was 1.96 was what I got.
But you have to subtract that answer from 1,000 and add it
Yeah,
to
you have to
1,000
add it
get
to 1,000 and subtract it from 1,000. That's right.
right.
Okay, so the way that I did it was, which I think that your guys' way is probably more accurate. But I did it simply just with that graph. Do you remember that little
Uh-huh.
chart that makes the 6895?
Mm-hmm.
And my answers were closer to B on the review. But I think your guys's are probably more accurate just because you plugged in the numbers into the equation. So then it looks like it would be 998.04 and 1001.96.
Uh-huh.
Does that sound right?
Yeah.
Mm-hmm.
Okay, so 998.04.
We
So
have to agree.
I think that your error is 1.96. Is that right?
That's just that's the confidence interval.
But I think it's the same number because it's 1.960 times
Equals the 90.
2 divided by the square root of 4, which is 1. Yeah, so it's 1.96.
Okay.
Okay, so the margin of error is 1.96. Is that what you're saying?
Yeah, because the
Okay.
z-score is 1.96. And you
Mhm.
multiply that by 2 divided by the square root of 4, which is 2 divided by 2, so it's 1. So 1.96 times 1 is 1.96.
Okay, so what we're putting into this, is it the margin of error,
For a 90%
the
confidence.
negative 1.96 and positive 1.96, or is it the 998.04?
I think that this margin, the margin of error is 1.96.
Okay, so
And
that's the answer for 6 then, is 1.96?
I think that's
Yes.
the answer for 6. Yes.
Okay.
2.
Okay.
So that's totally different than,
And the
I mean, the answer they're wanting is totally different than what we gave on the,
But the next question asks for the lower bound, which is the 998.040.
oh,
Yep.
okay.
So
Right.
998.04 is going to be the lower bound, and then 1001.96 is going to be the upper bound.
Okay, I didn't see those. I was confused. Thanks.
Yeah, so these questions are all jumbled.
Yeah.
But that's how come there's probably 32 instead of 26, is because they split them up.
Well, hopefully, yeah.
Hopefully, yeah.
Okay, so let's see then. I don't know which one this is going to be.
Number 6 in the book,
This is number
9 on the quiz.
9 on the quiz. Okay, so to assess the accuracy of a laboratory scale, a standard weight that is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean and standard deviation of 0.01 grams. How large should n be so that a 95% confidence interval has a margin of error of 0.0001?
So I got C on that one.
Me too.
I also got C
Yeah.
for that one. So, but it looks like we're needing to write down confidence interval.
38,416.
Yes, 38,416.
Yeah.
38,416. Okay. The next one, so this is going to be number 7 in the book. I have A.
That's what I have.
That's what I
That's
have
what I
too.
put.
I think is D on the quiz.
Mhm.
less than 1250. Yes, is D. Okay, and the next one I have B.
I had D on the next one.
I put D too.
D is in dog.
Yeah.
The results.
Okay. Okay, so let's see. In a statistical test of hypotheses, we say we reject the null hypothesis.
That's not the same question.
That's not the same question.
I
It
think,
isn't.
but I think in this one we say the p-value is less than A, right?
Right.
Because we're rejecting the null.
Yeah.
We reject the null, then P is yes, then P is less than A, so it's going to be B.
So is the way they worded it in the book, does that mean reject the null? They just worded it a different way?
I don't even remember how they did it, and I didn't write it.
So,
It says
so in the book,
test result is statistically significant at the level of significance if,
yeah.
yeah, I think that's what they're saying.
Okay.
And it's
Just in a different language.
say that the result, test result. What did you get for that, Jennifer, in the book?
I got D.
That's what I put too in the book, but maybe it's because I didn't understand the language they were using.
They do seem to say everything 5 different ways, don't they?
Yes.
So that the result.
But on the quiz, we know that's right, you know.
Yeah.
But
So we're going with 11 is B.
yeah,
Okay.
I'm just wondering if the book, you know, is that just a different way of saying that? I don't know.
You know.
Who knows?
Yeah, I don't know. Okay.
12.
Well,
Okay. A group of
This
statistics.
This next one's different too, because, oh, go ahead, sorry.
Oh no, you're fine. You're fine.
In the book, if I remember right, they didn't say the sample variances were nearly equal. They said the standard deviations
right.
Correct.
were equal.
Because I thought the same thing.
And they're 2 totally different things. And now they're saying sample variances. So they are changing things quite a bit.
You're exactly right. Question 9 says that the sample standard deviations are nearly equal, and in here it says that the sample variances are nearly equal, which makes a lot more sense for an ANOVA test.
Yeah.
So I mean, so it's going to be yes,
Mhm.
and then let's see, it is enough that the data for each part are bell-shaped with no outliers in the sample. So C.
That's
Yeah, but are they what? Aren't ANOVAs usually right skewed?
the main one is, but the individual ones, don't they have to still be normally distributed?
They still have to be a normal distribution, I'm pretty sure.
Okay.
Look, though, that's a good question, though. I can look that up real fast, too.
Because it's saying the data for each apartment building. So yeah, that makes sense.
Yeah, so it needs normally distributed data, populations with the same variances, SRS, and independent samples.
Okay. Yeah, that makes sense.
It looks like they've got all those.
Yep, I think they do. So I think C is what we should go with on that one.
Sounds good to me.
Okay. 13. Let's see here. You guys want me to read that, or what did you guys get for this one? I guess what would be the comparable one here?
Well, in the book, I put that she committed a type 1 error.
Yeah,
That's what I have as well.
I
is-
didn't.
I think whenever you, let me look at my thing. Whenever you reject the null, it's a type 1. And if you fail to reject, so if you reject the null and you're wrong, it's a type 1. If you reject if you fail to reject and you're wrong, it's a type 2.
Yes.
Okay.
And
this-
I really like that graph, that chart.
Yeah.
That kind of helps me understand it.
Which chart are you talking about?
So there's like a chart. Here, let me see if I can
Can you see?
let me see if I can. Oh yeah, exactly
Yeah,
what.
look at it.
Oh,
I don't know if that chart.
Yeah.
Right. Okay.
Have you seen that before?
Yep.
I would for sure write that that chart in your notes. It really helps me kind of understand the different ones.
Right.
Type 1
Okay,
versus
so-
type 2. So we're going with A for 13.
Yeah, I think so. Sounds right.
Let's see. Oh yeah, and this one, for this one, I put D for 11 in the book.
Yeah, I
Yeah.
did too. So that's A, right?
Correct. Yep. So it's A on this one. Because what we do to one, the opposite happens to the other, right? If one goes up, the other needs to go down.
Yes.
Yeah.
Okay. We've got. Is this one following in line with number 12?
Yeah.
So did you guys get B for 12?
Yeah. I did.
I got D for 12.
So reject the
this
null.
one, this one was tricky for me because it has a, if I remember right, didn't it have a 5%? It wasn't like a 90 or a 95 or a, wasn't it a 5%
Level of significance.
level of significance?
Yeah.
So then you'd have to make you'd have to do your A is gonna have to be, or excuse me, yeah, gonna have to be 0.95. Right?
No, isn't A the level of significance?
Yeah, but they're saying that the level of significance is 5%, not 95%.
And you have to subtract one minus A to get your oh gosh, I just can't come to think of the words of what I'm saying here.
1 minus A to get your level of significance.
Yes. So you have, like, for example, you've got when your level of, when you've got a 90%, your A is going to be 0.10. So they have to equal 1. They always have to equal 1. So like a 95% level of confidence is 0.05. 99 is 0.01. So if you have a 5%, then your A has to be 0.95 for it to add up. Am I on? Do you guys agree with that?
I think you're right, but on the quiz, they're saying it's a 0.05 level of significance.
Did they give that for us?
On the quiz, but not in the book. On the book, they're saying it's a 5%, and I wonder if that was just a typo.
5% does come out to be 0.05.
Exactly. So then do 1 minus 0.05, and you get 0.95.
But we
Does
don't
that make
have to
sense?
subtract it from We don't have to
1
subtract
minus
it from 1.
0.05 should be 0.95, shouldn't it?
Right.
Exactly. Yep.
So there, what she's saying is that should be our level of significance for this, for the one in the book. But I think that they've probably just made a typo.
Typo? I assumed it was the 0.05 is what we were comparing P to.
Yeah.
Which I think you made the right assumption, because I think that it probably was a typo, because in the quiz it's now saying 0.05 is the level of significance.
Uh-huh.
Yeah.
So I think we should base it off of A being 0.05 instead of being 0.95.
Sounds good.
So can you guys tell me what your equation looks like?
I did the z-score thing. I did z equals 1.53 minus 1.5 divided by 0.17 divided by the square root of 100.
That's what I got too.
And my p-value came out to be 0.0. Oh, the answer to that came out to be 1.765. And when I plugged that into the app, the p-value came out to be 0.0388. Is that what you guys got too?
Wait a minute. Can you read your equation one more time? So you had z equals.
I have z equals 1.53 minus 1.5 divided by 0.17 divided by square root of 100.
So for some reason I have z equals, everything's the same, but I had 1.54 instead of 1.53, but that must have been a mistake on my part, a typo.
Yeah, because it tells you that the sample mean is 1.53.
Oh, why did I do that?
Because you're human and we all do those things.
That completely changes everything. Okay. And then when you plug that into the normal probability applet, the z-score, like let's say it's a positive, I mean, mine's answer is going to be different, but it was a 1 point something, right? You highlight all the way up until that 1.569 or whatever it is, right?
Let me see. Greater than. I would highlight to the right. I highlighted to the right of the 1.765 because we're looking at a greater than.
Okay, yes, because it's higher than advertised. Correct. Okay.
Okay, so what did you get? Your number was 1.765?
Yeah. That's what I got for my z-score.
See, I'm getting a 0.176 for my z-score.
0.176?
Uh-huh. So 1.53, whoops, let me do that again. 1.53 minus 1.50 divided by 1.7, or no, 0.7.
0.17.
That's okay, sorry.
I also got a 1.765 for the z-score.
By 100. Yeah, okay, sorry. I put 1.7 for my standard deviation instead of 0.17. Sorry.
Okay.
So 0.039 is our P.
Yeah.
Okay. We failed to reject it? No.
No, we're reject the null.
Rejecting it. Okay.
Make sure you get the null and not the alternative.
Yeah.
Yeah.
So we are rejecting
So that's D.
the null. Yes.
Okay.
Perfect. All right, the next one is you would like to look at the mean number of hours worked for wages per week by male students and female students. You would like a random sample of 100 to test if the means are different. What is the correct statistical procedure? Let's see.
Independent.
I believe I put independent samples test, but would this be number, I think I put D for this one.
Yeah.
I put D2, and I think independent samples
So it would be
was the
B on the quiz.
Yes.
Okay. The next one, I believe I also put D.
I did too.
So let's see, that's going to be,
His brothers and sisters.
That's dependent.
It's going to be D again.
on the quiz.
Mhm.
Yeah.
B is in boy,
D is
A
dog.
and dog.
dog.
Even dog.
Dependent sampling. If you select a brother as to compare that, you must include the sister. Yep, that's right.
That's as far
So
as
that's one where they're dependent, because if you choose one, the brother, the sister's automatically selected as well, right?
That's right.
yeah.
Mhm.
All right, so the next one we've got here is, oh, did you guys say this is where you ended off?
Mhm.
As far as I got.
Okay,
I'm sorry.
that's okay. Go through the random sample from the field, from the dissolved carbon.
Oh, okay. So we need to open some.
Yeah, so you'll need to open the dissolved organic carbon file. Has anybody done this one? Jennifer Ward, have you done this one?
I did.
Did you get B?
Yes.
So B is a confidence interval for mu when sigma is unknown. So let's see.
Now, I had a question because this is my brain thinking.
Yeah. Yeah.
But so when you do plug in all those numbers into the Excel,
Mm-hmm.
then you do know sigma. So, but we don't worry about that, right? Until it's kind of like the question is asked before we put all this information in, right?
Yeah, I think so. That's how I took it. Because
Okay.
initially, well, oh yeah, okay. So here, this will make sense. So in order to decide what test to use for them, we had to know that the sigma was unknown. Otherwise, we would have probably performed the wrong test for it. Does that make sense?
Mm-hmm.
Because if the sigma is known, then you'll perform a different.
We'll do a Z test instead of a T test.
Exactly. So I think, yeah, this is the kind of a question you kind of ask in determining what test to perform.
Okay.
Okay.
And so we know that the sigma is unknown for that one.
Okay. So Jennifer, do you have your information in?
Yeah.
I
Jennifer, sorry.
do not yet.
Okay. I always try to say Jen and Jennifer, but sometimes I don't. Get it right.
And I go by both, so I don't. So question 18 is A on the quiz.
Yeah.
Yes.
Okay, going in the one sample t-test.
Yes.
I have it in.
Okay. So we can go to 19.
Yeah. Let me look. What's the null hypothesis? Because I know that's not right on this. Has it stated a... Okay, well,
Oh.
Ooh.
okay, so 18 we did A, right?
Yeah.
Uh-huh.
Okay.
What did you guys get for your margin of error for the 95% confidence interval?
0.967.
Okay.
But yeah, so do we,
I got-
so what is the null hypothesis?
I don't think, does it matter because your confidence interval is not going to change because of that?
Yeah, it does change.
Oh, it does?
I've got a different...
Oh, maybe it doesn't. No, I think it only changes if you do greater than, or no,
It doesn't
yes.
change.
the p-value changes. That's what it is.
Mm-hmm.
Mine doesn't.
If
My
you-
p-value does when I change the null hypothesis.
The p-value does, but the confidence interval
Right.
doesn't.
Right. You're right.
So what did you guys get for the margin of error? Oh, maybe I don't have it set to... No, it's set to 95. I got 4.148.
You mean like the standard error of the mean, that one?
No, the margin of error for the 95% confidence interval for this.
Oh, yeah, the difference.
Yeah, you take the larger and you subtract the smaller, right?
Yeah, you're right.
Do we need that for a test or a question? I'm not even looking at
Uh-huh.
Yeah, for number
So
9.
it. Oh, okay.
So you take the upper bound minus the lower bound, right, and divide by 2?
Yeah, so I get 2.025.
You divide by 2. Oh, that's right, because they're two different halves. I forgot that.
2.025.
So 2.025?
2.025 is what I get.
I got 2.074. Let me check my numbers.
15.217.
2.025, is that what you guys got?
Yes.
Yeah.
Okay.
I wonder why my numbers are off.
So what is your confidence interval? What's your low number?
My low number is 11.361.
Mine's 1.68. Mine's 11.168.
Mine too.
Let's see.
wonder-
What's your N? Do you guys have 19 for your N?
20.
20.
20?
Yeah, so I think you're just missing a number.
Okay.
Probably your first or last number, I would guess. Your first number should be 14.367 and your last number should be 8.587.
Yep, there it is. That
So
should
is
make-
your upper bound 15.217?
Yes.
There. It is now, yeah.
Perfect.
Okay, so 2.074. No, 2.025.
25.
Jennifer Ward, did you get for 17 in the book D?
17?
In the
Yeah.
book.
Yeah.
Okay.
Oh, this is one of those horrible, all sorts of things to sort.
So it looks like 22 is going to be C on the quiz. That matches up with our.
Yeah. Okay, and what are we looking for here?
So you're going to do the same thing. You're going to do a 95% confidence interval and find the lower bound and the upper bound. So just plug in your numbers into the independent sample test. And then you're just looking for, make sure it says 95% confidence interval. And then you're going to input the lower bound and input the upper bound.
So in an ANOVA test?
No.
No, the two sample t-test, I think
Not
is what it's
fair.
called. The independent sample one.
Okay.
Two sample.
So I'm looking at, okay, I need to read the question. Sorry, hang on. They're all in order from Los Angeles to New York. Okay,
Yeah.
okay.
Jennifer Ward, what did you get for your lower bound?
Negative 423.
Perfect. Did you get a point? 0.238?
No.
Oh, you didn't?
Where does that come from?
Sorry, for 22, we're going with C. Is that right?
Yes.
Yeah.
Okay.
Oh, weird. I don't know why why I got a decimal when I did it. And then is your upper bound 5,417?
Yeah.
But you didn't get a 0.336?
For the lower bound?
Sorry,
the-
for the upper bound, 5,417.336?
No.
Ah, son of a.
Okay, well, we have the number right, so let's see what they get for their upper and lower, and maybe, I don't know, that's weird.
That's not even a choice in the book.
I think I went with C because it was
Yeah.
basically the same numbers, but I wonder why I got decimals.
Okay, so you're talking about your confidence interval?
Uh-huh.
Yeah, I got decimals, negative 423.238.
You know,
Okay,
Jennifer
that's where
Ford, I'll bet when you did it, you got decimals, but because the answer didn't have the decimals, you probably just wrote it down without the decimals. You know what I mean?
Yeah, I just circled.
Because that was the option that they gave. So when you write it in for 23, make sure you put negative 423.238.
Okay, gotcha.
And then for 24, you're going to go with 5417.336.
336. Okay.
Is that what you guys got for the upper bound as well?
Yeah.
Okay. All right.
Yeah.
So yeah, you guys get to open up another one. Exercise bone density.
All right.
So I was still working stuff. So for the lower bound, negative 423, etc.
0.238.
0.238. Yeah. Okay.
Yep.
Okie dokie. Sorry, guys.
You're okay.
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 Okay, exercised bone density.
Groups, control. So is this an ANOVA test?
Yep.
3 groups. All right.
So 25 is going to be C.
Yes. Okay. So now, let me open up this one.
Jennifer, Jennifer Ward, what did you get for the test statistic?
7.978.
Oh, crap.
That doesn't mean it's right.
Oh, man. I got 1.685.
Well, that's not even a choice, so maybe that's wrong.
Wait a minute. What
There is
number
an
is
advantage
that?
in multiple choice. Let's see.
What number
Are we
is
working
that?
on 26 on the quiz?
20,
Yeah.
what number is it on the homework?
20?
Oh, I'm looking at 24. 20 I got, oh yeah, my bad. 7.978.
Yeah.
Okay, no, we got the same score. I jumped ahead.
Okay.
That's the next test statistic for the next one.
Okay.
7.978. Yeah, that's right.
I didn't do that very last problem because that's when my computer just like started freaking out.
And then was your P 0.002?
Yeah.
Okay.
Okay.
So now we can do it all over again since I've got all my stuff in. Okay. Do you have yours in, Jennifer?
26, I got 7.978.
Yes. Okay.
Okay. And
E value, I've got 0.002.
0.002.
Huh?
Yep. And then 28, it looks like. Did you guys get fail to reject the null for, so there's insufficient evidence?
No.
Got sufficient evidence to conclude that the mean bone density of at least one group is different.
Oh, Erica, yeah.
So that's what D, that's what I was looking at.
P is low, right? So reject the null.
Yeah.
So we're going with D there, right? The fourth one?
Dog.
Dog, yeah.
So there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Yeah.
Sufficient. Good. Okay, so I had a question on this one. The direct flight costs, aren't they dependent upon each other?
Yeah.
Yeah,
So
because
it
they're using the same flights just on 2 different days. So yeah.
Mhm.
So it would be a dependent samples test.
Yeah.
So E for 29. So T.
So that's a 2 sample T or paired sample t-test.
Dependent samples test is what they're calling it today.
saying it's a paired, right?
Yeah.
Correct. Did you guys get the test statistic for that was 1.685?
I haven't gotten that far yet. I'm
Me
still
neither.
plugging in.
Wasn't there?
And is this the one that had, I think we like reviewed it before, and it had some that like,
Had nothing in it.
yeah, so you had to fix that? Or
Do you
just
maybe-
have to do that, or can you just leave it?
I just
I-
left it.
I did
and you got
too.
the right answers?
Yeah.
I think so.
Huh.
You just left it? And
Uh-huh.
see, I didn't get the right answers when I left it.
That was what happened with me too.
Maybe I
And-
didn't have the right
I know. maybe-
It seems like I read something in the book about that. And so I just said, if there are not both numbers available, then you do not use that information at all.
That would make sense.
Because then you don't have a difference of anything really. And then it throws everything off, seems like.
I I copied the same data twice.
Oh no. So what did you guys get for your T-score?
I got 1.685, but I left it. I didn't change. I didn't delete anything.
Okay, let me delete those ones and see if that changes. It does change the means of
Oh, crap.
stuff.
What did
Yeah.
you get for the T-score?
But it didn't change the T-score. It just changed the variable means.
Okay.
So I still
So-
got the 1.685.
Okay. Perfect. So what was the only thing that it changed?
It looks like the only thing it changed was the variable means and standard deviations, things like that, just on the variables. But I'm not positive
Okay.
about that. So what did you get for your p-values?
0.007.
0.096.
0.096, yeah, 0.096.
Okay.
So did we, let's see. So the P is low. So reject the null.
Oh,
Yeah.
wait, I didn't put it in it as a 90%.
Oh, is it supposed to be 98?
Well, maybe it's
99,
95 at the beginning, but this question is 90. Number 32 asks for 90.
Okay.
Oh, so do you need to change the?
Well, I'm wondering, I need to go back and look at the first question. Yeah, it's a 90%. So that,
It changes the confidence interval, but it doesn't change the p-value.
you know.
Okay.
And is it, and what's the, okay, hang on. Sorry, what's the null here? Is it,
So the null is going to be. Was it different? I can go back up and look.
Okay.
Yeah, so if there's a difference, so not equal to.
Okay. All right.
So if we're rejecting the null is that they're the same, right? Wait, let me see here.
What do you guys put for your null hypothesis?
Is that the null is that they're equal to?
So it would be a 0.
Equals
Zero.
0.
Huh?
The null hypothesis is going to equal 0 because you don't want to. It's testing for the difference.
Okay, which of the best? Zero. So we're rejecting the null, right? Sorry, I'm
Yes.
Yeah.
okay. So
So
that
not equal to 0. So
So it's B, isn't it?
B,
B as in boy.
Yeah.
boy.
so the null is saying that there is not a difference, right?
Right.
Right.
And so the alternative is saying that there is a difference.
So B.
Yeah.
All right.
Hey,
Should I
that's the last one.
submit it? I'm going for it. Fingers crossed. Please don't have one wrong. Please don't.
You get a level of anxiety when I submit.
Got it right. 30 out of 30.
Awesome. Oh,
But there's 30. Oh, well, they don't count for full points, probably.
Right.
Sweet.
so what else are you guys planning on doing to study for your quiz?
Well, I'm worried about, there's going to be questions from the last test on there.
Yeah.
And so I guess going over that stuff too.
I'll bet you there's going to be, like, definitely the central limit theorem stuff is going to be on there. And the law of large numbers. I think those are things for sure she's going to bring back, like main concepts.
Was the type 1 and type 2 errors on the first test?
No,
I can't. It all just kind of runs together for me.
it was in lesson 9, so that's where we started.
Okay.
Yeah. I hope. No, I hope there isn't too much on the previous stuff because, man, I